Here we have chapter 8.1 dealing with parabolas. These first three formulas here are the traditional formulas for a parabola that we've worked with throughout the year. We have the basic quadratic equation, just your basic parabola with no shifting with the vertex at 0, 0. And then finally the equation or formula that has the shifting aspect with the h and the k. What we're doing now in chapter 8 is working with a new form called transformational form. And there's two setups, one for a vertical parabola and one for a horizontal parabola. And the vertical parabola is written as x squared equals 4 times p times y. And the horizontal is the y is being squared. So it's y squared equals 4 times p times x. Both of these equations, the way they are written, these formulas, are when the vertex is at 0, 0. And down below, you can see I have equations written with the h and k. So when you have the h and k written in there, it is accounting for the shifting or transformation of the graph on the coordinate plane. So basically your vertex is going to be moved to a different location other than 0, 0. And the h and k would help you to be able to identify that. So when we look at these equations, these formulas, what we're looking for, or what we want to identify, is that 4p value. That's why I have that highlighted in red. Okay, because the x squared and the y, or the y squared and the x, those are your variables of the equation. So you're going to be given a number multiplied by the y, or a number multiplied by the x over here in the horizontal. And that number is going to help us find that p-value that we need for the thing that's called the focus, and here for the directrix and the focal diameter. Okay, so it's very important to know that number right there and know what to do with that number. Like I said, these functions are written for the vertex of 0, 0. This focus is this point right here in the middle of the parabola. If we're looking at the graph right here, this point right here is the focus point. And the parabola kind of wraps around that a little bit, and that's called the focus. And the distance from the vertex to the focus is that value of p. Okay, so whatever number is here up in the equation, you're going to divide by 4 to find that number p. And then the directrix is just the opposite value. So then that's a line that is perpendicular to the direction of the parabola. So if the direction of the parabola is vertical, then the directrix line is horizontal. Over here, where the parabola is horizontal, the directrix is vertical. Okay? And the focal diameter tells us the width of the parabola going through the focus. So that 4p value as a positive number, because it's measuring distance, is the focal diameter. So that value, whatever it might be, is the length from one side of the parabola through the focus all the way to the other side of the parabola. Okay? So in essence, both sides here are 2p. So you've got 2p on this side and 2p on the other side to total up 4p. Okay? Same thing over here. This is 2p from the focus to the edge of the parabola, and on the other side as well is 2p. When we look at the function with the shifting, okay, the h and the k, for the vertical, you are adding the p to that k value. Up here in where we just had 0p, you're adding to 0, so p plus 0 is just p. But when we have a vertex at hk, then you have to make sure for a vertical parabola, you're going to be moving up or down to find your focus. In this case, with my parabola drawn here, my focus is going to be up by however number of units of p. So I'm moving up and down, which is my y value. And so no matter where my vertex is, whatever that k value is, that y value from the vertex, I'm going to add my value of p to find my focus. Even if I am got a parabola that's got a focus that's going to be moving down from the vertex, the p-value is just going to be negative. So you're still adding it to the y value. Okay, and that's what would bring it down because of the negative value of p. So that's going up and down, and that's why we're adding to the k value of the vertex. In the horizontal, it's going to be moving left and right, the focus. So you're adding to the x value of the vertex, which is your h value. And so if you've got a parabola going to the right, you're going to be adding, and it's going to be a positive p-value. So you're adding, and that focus would be moving to the right of the vertex. If I have a parabola that is going off to the left, that p-value will be negative, and when you add to the x value of the vertex, that will be moving that focus to the left of the vertex. Okay? And the directrix is just the opposite direction, so you're just subtracting from k. So that's just going to be, if you know how many units it goes from the vertex up to the p-value, you can just count down, or the opposite direction from the vertex to draw your directrix. And then the focal diameter is still the same. You're still going to have the absolute value of that 4p value. Okay? All right, let's get into some examples here. For this example, we want to find the vertex, focus, directrix, and the focal diameter, and then sketch the graph. Okay, so what I'm looking at is this 8 right there. As I said, that number 8 is my 4p value. So I'm going to take 4p equals 8, and I'm going to solve for p by dividing by 4, and I get p equals 2. Okay, I have nothing added or subtracted to my x and y, so my vertex is 0, 0. And I know that this is a vertical parabola because it is x squared and it's following that function. So x squared equals 4py is a vertical parabola. So I know that this is a vertical parabola, and that means I'm moving up and down for my focus. So I know that my focus value has got to be, it's going to be the y value for the point here. So my p value is 2, so I know that my focus is 0, 2. My directrix is the opposite, so negative 2, and it's going to be an equation. So if I've got a parabola that's vertical, my line is horizontal. Horizontal lines are y equals, and my p-value is 2, so I'm taking the opposite of 2 to be negative 2. And that's just getting to know those little formulas from the notes here. These formula right here, the 0p and y equals negative p. And then the focal diameter is the absolute value of the 4p value, which is just the 8. You get that straight from the problem right there. So whatever that is, positive or negative, make it positive, take the absolute value, and so my focal diameter is 8. And now I'm going to go over here and start to graph. So I'm going to plot my vertex at 0, 0. I'm going to use a brighter color here. Okay, so 0, 0. And then I'm going to draw my focus, 0, 2. All right, my directrix is then the opposite direction, and that's a horizontal line. That's a terrible horizontal line, but you get the idea. Let's see if I can do it better here. I'm going to grab a line, and we'll make it red. So there's my line. Okay, that's my directrix. And my focal diameter is 8. Well, that 8 value, okay, think about a parabola. That's going to be, if this is my focus, it's going to be all the way across. That's The total value is 8. So if this focus is in the middle, then I need half of that 8 on the right-hand side of the focus and half of it on the left side. So I need to split that 8 in 2. So if I take 8 divided by 2, I get 4. So that's 4 units on the left and 4 units on the right. So when I count this out, I want to be able to do that. So I'm going to go 1, 2, 3, 4, okay? And I'm going to count left 4 units. 1, 2, 3, 4. And that's a total of 8. So the focal diameter is all the way across. And now I'm ready to draw my parabola going through those points. Okay, that was terrible. Let's try that one more time. That's a little better. Okay, and so I have my parabola, and knowing that this focal diameter here was 8. Let's look at this next example. Again, we're going to do everything we just did up above. Here we've got y squared equals negative 3x, so this is a horizontal parabola. And the other thing I need to realize is this is negative, so this is opening to the left. It's horizontal and opening to the left. So again, I still need that negative 3, and that's my 4p value is that negative 3. I'm going to divide by 4, and I get p equals negative 3/4. So my vertex, I still have nothing being added or subtracted to x and y, so that's 0, 0. My focus, now because it's a horizontal, that my focus is going to be moving left and right. So my p-value needs to be in the x-coordinate of my point. So negative 3/4, comma 0. My directrix is going to be the opposite, so positive 3/4, and it's going to be a vertical line, so that's x equals 3/4. And then my focal diameter. My focal diameter is the absolute value of negative 3, so my focal diameter is positive 3. So let's go over here and start graphing. I'm going to plot my vertex first. My focus is at negative 3/4, 0, which is right about there. And my directrix is going to be at positive 3/4. Let's see here. Let's get a better red. And that's about right here. All right. So there's my directrix. And now I need my focal diameter. All right. So 3 units. That means if I divide 3 divided by 2, I get 1.5. So that tells me 1.5 units, okay, here up and down. So 1.5 units up, which is right about there, and 1.5 units down, which is right about there. And now I'm ready to graph. Oops, there we go. Let's round that down a little better. Okay, and there's my parabola, a very rough sketch. With my focal diameter is 3, so if I count this out, I can count 3 units. Okay? All right, let's look at this example. Find an equation for the parabola that has a vertex at the origin and satisfies the given condition. Okay, they're giving us the focus here. Well, the focus is our p-value, and since it's the x that's moving left and right, so this is a horizontal parabola, which means it is y squared equals 4px. Well, when they give us the focus, they're giving us the p-value. All we need to do is plug in the value for p. So y squared equals 4 times 5 times x, and we get y squared equals 20x. Pretty much the same for the directrix over here for number 2. They're giving us the negative p-value. So if negative p equals 6, then that means the positive p equals negative 6. You're just dividing by negative 1. With this directrix being y equals 6, that's a horizontal directrix. That means this is a vertical parabola, which means I have x squared equals 4py. and my p-value is -6, so I'm going to plug in -6, and I get x squared equals 4 times -6 times y, and I get x squared equals -24y. Moving on to the third example here. Find the vertex, focus, directrix. So we're going to find all those values and graph this. Okay, this one here is not in the correct format right now. What we need to do is get y squared by itself. So the first thing I need to do is subtract the x. That gives me -2y squared equals -2. And I'm going to divide by -2. What am I doing? So -2y squared equals -x. And I'm going to divide by the -2. And I get y squared equals 1/2 x. So this right here is my 4p value. So it's a fraction, but that's all right. So 4p equals 1/2. I'm going to divide by 4, and I get p equals 1/8. All right. This was y squared, so this is a horizontal, and p is positive, so it's horizontal opening to the right. And there's nothing added or subtracted to x and y, so my vertex is 0, 0. My focus is that 1/8, okay, and this is a horizontal parabola, so my focus is going left and right, which is the x value. So that is 1/8, comma 0. My directrix is going to be vertical, so that would be x equals -1/8. And my focal diameter is that 1/2. Sorry about that. Okay, and now we're ready to graph. So we're going to plot our 0, 0. We're going to plot our focus, which is super close at 1/8. Our directrix is also at now at -1/8, which is extremely close to the line. Oops. I want that to be red. So let's do this and make the line thinner. Okay. So at 1/8, it's approximately right there without getting too cluttered here. And my um, focal diameter is 1/2. So if I take that and divide by 2, that's 1/4. So that tells me, I'm going 1/4 of a unit up and 1/4 of the unit down for half a unit. And it's a very narrow parabola going to the right. And then we have this last example where you can see we have numbers in here, adding and subtracting from y, although we have -6y plus 12, so that -6 isn't on the outside. So what we need to do here is we need to factor that -6 out so that this says -6 times y minus 2, because now that would be in the proper format for us to be able to identify the vertex and everything like that. So from this, this is already set up nicely. My vertex is going to be the opposite value of these here. So we have -5 and +2 for my vertex. My focus, okay, have my 4p value equal to -6. And I'm going to divide by 4. And I get p equals -3/2 or -1.5. So with p being equal to -1.5, then also this is in the format of x squared equals 4py. So this is a vertical parabola. And so we're going to have -1.5 comma 0. And the directrix is going to be, I'm sorry, this is going to be 0 comma -1.5. because the focus has to go up and down. And then the directrix will be horizontal, so that's going to be y equals positive 1.5. And my focal diameter is the 6. And remember, it's absolute value of that number. All right, so now we're ready to graph this. So our um, vertex here would be at negative 5, 0. I'm going to put some lines on here. Let's see. Um, okay, that in a little bit. And now I'm going to, well, extend these here. Hopefully I have enough. If not, we'll get through it. Okay. So then negative 5, 2. So 1, 2, 3, 4, 5, 2 is right here. My focus is going down 1.5 units. Oh, you know what? This is not 0, negative 1.5. It's negative 5. And then I have to subtract or add negative 1.5 to my k value. So 2 plus the negative 1.5 is going to be positive 0.5. And so really, this is now zero point 0.5. And so then, but knowing where my vertex is, I'm going to count down 1.5 units, which gets me to that 0.5 right there. Okay, and my directrix here is going to be up 1.5 units. So that's going this way. And my focal diameter being 6, that means I'm going to, if I take 6 divided by 2, that's 3 units to the right over here, and 3 units to the left, which is over here somewhere. Without my lines going out there, I'm not quite sure where that is going to be. Okay, and then I am ready to draw my parabola, so I'm going to go out through that point. This is not the best parabola drawn, but that's all right. You get the idea. Okay, and let's see here. Come on, move that out there. Okay, and that's it.